Good morning, I'm Laia Haurie and I'm going to present you some insights about the study that we have performed of the fire behavior of bamboo, Guadua angustifolia. Bamboo is an excellent material with mechanical properties suitable for building applications, a renewable source, and a fast growth and climate adaptation plant. But it can undergo flaming, so we have studied the influence of the following parameters on the fire behavior of bamboo: moisture content, the microstructure, and how we can improve it by adding some flame retardant. We have chosen a commercial bamboo and we have extracted samples from the different areas of the bamboo, selected two conditioning methods, and added two flame retardants in order to improve fire behavior of bamboo. The first part of our study involves the scanning electron microscopy sampling in order to observe the morphology and chemical composition of each cross-section, and the fire testing through the pyrolysis combustion flow calorimeter that let us evaluate the heat release rate of the different bamboo samples, the Epiradiator, in which we assess the self-extinguishability of the samples when they are subjected to an external heating source that is removed after the first ignition and relocated when the flame is extinguished, and the determination of the limiting oxygen index, in which we evaluate the minimum oxygen concentration which allows the sample to sustain combustion under the conditions of the standard. In the scanning electron microscopy, we can observe that the external part of the bamboo shows a smooth surface rich in silicon. The central part has an ordered structure with parenchyma, vascular cells, metaxylem and metaploem tissues, and a lower silicon content. And the internal part is poorly structured, with some areas covered by white fragments and rich in silicon. In the pyrolysis combustion flow calorimeter, we observe that the heating release rate is influenced as expected by the moisture content, leading to a lower value of total heat release rate, but no significant difference is observed according to the section at which the sample was extracted. However, in the Epiradiator results, we can observe that the external layers, richer in silicon, show higher ignition times and higher amounts of residues, but when the flame appears, the persistence of this flame on the sample is also higher than for the internal and central parts. And as expected, moisture contributes to increase the appearance of the first flame, so the ignition time, and also the amount of residue. With regard to the presence of flame retardant, we can observe that in both cases, boron and phosphorus-based flame retardant reduce the duration of combustions and increase the amount of residue. But they can decrease the time at which the first ignition appears due to a lower thermal stability of the flame retardant samples. In the limiting oxygen test, we observe that the moisture hinders the combustion of the samples by increasing the oxygen index value, and that both flame retardant can improve the fire behavior of bamboo sample by significantly increasing the oxygen needed to sustain the combustion of these samples. In the case of the phosphorus-based, this effect is higher than for boron-based flame retardant at the concentrations tested. Our conclusions are that the equilibrium moisture content hinders the combustion of bamboo, but does not significantly change the fire reaction of bamboo. The areas richer in silicon, especially the outside areas, show better fire behavior. The addition of 5% of boron-based flame retardant improved the fire reaction of bamboo by increasing self-extinguishability and limiting oxygen index value. The same trend, the addition of 15% of phosphate-based retardant further reduce the duration of combustion under the radiator and give rise to higher Laia values. And both mechanisms of action, the formation of a protective glassy layer, which is the main mechanism of action of boron-based flame retardant, and the promotion of charring, due to the presence of phosphate flame retardant, lead to a clear improvement of the fire behavior of bamboo. It would be interesting to further study the effect of similar concentration of these flame retardants. Thank you for your attention.